Okay, so when we write our parametric equations, it says that our velocity is 150 and the angle is 30. And in golf, when you hit the ball, you hit it from the ground. So the initial height is 0. So let's look at our equations. Our first one, x of t equals 150 cosine 30 t. And then your second parametric equation, which is your vertical distance, we're using 32.2 for our gravity. When we take that and multiply it by negative 0.5, we get negative 16.1. T squared plus 150 sine 30t, and then our height is 0. All right, so do we agree with those equations? Okay, so it says, how long was the ball in the air? So we have our golf ball. It's hit. I don't know how far it traveled, but I do know whenever it's on the ground, the vertical height is 0. So I'm going to use this equation to solve for t. So let's take this equation for part B. And I have 0 equals negative 16.1 t squared plus 150 sine 30 t. And in order to find t, we're going to take out our GCF. And our GCF is t. And when I take that out, I'm left with negative 16.1 t plus 150 sine 30. So now let's set both of those equal to 0. And when I do that, this t equals 0, that represents when it was hit initially. This is t equals 0. And to figure out how long it takes for it to return to the ground, we take this factor. We're going to set that equal to 0. And solve it. So the first thing I'm going to do is subtract 150 sine 30. And then I'm going to divide by negative 16. So t is going to equal negative 150 sine 30 divided by negative 16.1. And when you type that in your calculator, you should get that the second t value is 4.658. So that's how long it takes for the ball to return to the ground. T equals 4.658 seconds. And that is the answer to part B. How long was the ball in the air? Okay, so let's read question C. Question C says, when was the ball at its maximum height? And then we need to figure out what the maximum height is. So thinking about a parabola, when is the parabola at its highest point? In the middle. So that would be right here. Right in the middle. How do you figure out the t value in the middle? take that 4.658 and divide it by 2. So for part C, T equals 4.658 divided by 2. So when you type that in your calculator, 4.658 divided by 2 is what? 2.329 seconds. So that answers the question of when, but now we need to figure out the height at 2.329 seconds. So when we talk about height, we're talking about the vertical distance. So which parameter am I going to substitute this into? Is this X or Y? It's Y. Because when we talk about height, that's your Y value. So the height, that's this right here. See, this is a vertical distance that we're trying to figure out. So it's asking for the height of this ball right here. What is that height? So I want you to take this 2.329 and substitute it in for T in your Y parameter. So Y equals negative 16.1 T squared plus 150 sine 30 T. And now you're going to take that 2.329 and substitute it in. So go ahead and do that. Type that in your calculator to figure out what that height would be right in the middle. So did you get 87.345 feet? That's your maximum height. And that would be the answer to part C. Now to figure out for part D, it says, what is the distance? So it's asking you, this is where it started, this is where it landed, what's the distance? So the distance, that's going across. So I need to know the distance at 4.658. So what parameter is going to give me the horizontal distance? X. So take 4.658 and substitute it in for T in the X. Use your X parameter. And you should get 605.092. Requires us to do the quadratic formula, so let's not do that today, okay? What I want you to do, though, is I want you to read number five, and we see if you can get it started, okay? Read question number 5. I think with a word problem, you know, they're a little bit trickier, but what I always do is I read it twice, honestly. I read it the first time, and then the second time I read it and I try to find my key values in there. So go ahead and read question 5. We're going to skip 4 for now. Come back to it. Read question 5. See if you can visualize what is happening, if you need to draw a little picture to help you visualize it, and then we'll talk about it together in a few minutes. So in many U.S. parks, campers must secure food and provision from bears and other animals. One method is to secure food using a bear bag, which is done by tossing a bag tied to a rope over a tall tree branch and securing the rope to the tree. Suppose a tree branch is 30 feet above the ground and a person is 20 feet away or 20 feet from the branch, throws the bag from 5 feet above the ground. So the branch, we're kind of like, because we know how far away the person is, so I know that this person is 20 feet away from this tree, right? Okay. And the branch that he's trying to tie it over is how far off the ground? 30 feet. So I know, because I know that he's 20 feet away, I can use my X to find T. And then I can use that answer to figure out if it's going to be high enough. Because we know that he's trying to get it up 30 feet. So let's write our parameters really quickly. Yes. Alrighty, so let's write our equation. So the first time we try, we used a speed. So speed is the same as velocity of 40, and the angle is 60. Okay, so we're going to use velocity of 40, and the angle is 60. So 40 cosine 60 t. And then my second equation, y. So am I using 32.2 or 9.81? 32.2. So I always just take that number and multiply it by negative 0.5, which is negative 16.1. Plus 40 sine 65 t. Now, it also says that when the person, 40 sine 60 t. So negative 16.1 t squared plus 40 sine 60 t. Okay, but when you read that, it says that how high above the ground is the person, are they throwing this bag? So they're not throwing it from the ground, like they're not laying on the ground. They're 5 feet above the ground. So we have to ask, this is our first time where we actually have an initial height that's not 0. Okay, but because I know that we are 20 feet away, I can use my X parameter and solve for T. So I want you to use your X parameter. Now, if we didn't know that, we would have to do it totally different. And we'll talk about that tomorrow. So for this is still part A. So we're going to take 20. That equals 40 cosine 60 t. Now, depending on your calculator, you may have to include parentheses around that 40 cosine 60. But you should get t equals 1. So if you're not getting that, try it again, and this time put parentheses around 40 cosine 60. If your calculator doesn't have a fraction option. So 20, he's 20 feet away. The horizontal distance is 20 feet. And because I know his horizontal distance, I can divide that. I can use my x parameter and solve for t. So 20 divided by 40 cosine 60, you should get 1. Who got 1? Okay, good. Okay, so hold on. Okay, so what we need to figure out though, because we needed to clear the branch that's 30 feet high. We need to figure out what is the vertical height of that bag at 1 second. So we know that it's going to take 1 second the first time. It's going to take 1 second for it to travel 20 feet. But we need to know how high is it going to be at that time. Because we need it to be at least 30 feet high for it to go over the branch. So how do I figure out the vertical height at 1 second? So you're going to take that 1 and substitute it in your y parameter to see what you get for your vertical height. So we know that at 1 second, we have that. So now let's figure out our vertical. So y equals negative 16.1 t squared plus 40 sine 60 plus 5 Go ahead and type in the 1. Type that in your calculator. See what your vertical height would be at 1 second. We need it to be more than 30 for me to say, because we want to see, is it going to go over the branch? And the first time you should get that the vertical height is 23.541 feet. So no, it does not go over branch. Will not go over. So what I want you to do is try to do part B by yourself. So the second time, the person is using a different angle and more force, more velocity. So write a new set of equations, and you're going to do it the exact same way. You're going to find t, and then take that t value and substitute it in to find your y value. So take a moment, try to do part B by yourself. I'm going to give you about 4 minutes, and then we will work through it together. I'm a little tongue twisted today. Okay, so to find your t value for the second scenario, you would take 20 and divide it by 45 cosine 75. So what did you get for t the second time? Okay, so 1.717 seconds. So this time, let's figure out the vertical height. So what is your vertical height at that time? So I'm going to take that 1.717. And when you type that in, straight across, negative 16.1 times your t squared plus 45 sine 75 t plus 5. What did you get for your vertical height? 32.168 feet. So is it going to go over the branch this time? Because how high is the branch again? 30. So this time he used enough force and it did clear it. So you would say yes for part B.
Is it okay if I rounded it to 1.72?
That would be okay because it didn't specify where to round to, so that would be okay. I always do thousandths place, but the bottom line is you would still get a height. Your height would be close enough and you would know that the answer is yes. All right, so again, homework 18 due date has been pushed back. If you are doing a retake today or tomorrow, please remind me so I can make sure I have that retake ready for you. I stay after on Tuesdays. I have 6-period prep, and if you come in, you can come in at any time. So it doesn't have to be 6 period. I just teach during the other times.